¿Qué tal? Buenos días. Bon dia a tothom. ¿Cómo estáis? ¿Habéis descansado? Espero que sí. Vaya jornada intensa tuvimos ayer, esa primera jornada de este EdTech Congress Barcelona. Hoy nos espera también, un día interesante. Tenemos un día interesante por delante. Estamos de resaca emocional, yo creo, todos los que estamos aquí, con todos los temas que se tocaron ayer, con las reflexiones de los ponentes de auténtico lujo que pasaron por este escenario. Yo tengo personalmente muchas ganas también de escuchar a los protagonistas del día de hoy. Fijaos, se ha debatido mucho, obviamente, sobre todo lo relacionado con la innovación dentro del sector educativo. Tengo en la cabeza a Mark Prensky hablando muchas veces, además, de crear esos entornos colaborativos donde se involucren a todos los agentes dentro del ecosistema educativo, ¿no? O sea, las familias, los alumnos, los centros, obviamente los profesores, los directores de esos centros educativos. También se hablaba mucho, lógicamente, de nuevas metodologías, de evidencias. Esta palabra, además, la destacaron varios ponentes a lo largo del día, de ese aprendizaje adaptativo, inmersivo, de alguna tecnología concreta también, como la inteligencia artificial. Y en el Discovery Stage me quedé, además, con la copla de esa alegoría que hacíamos en cuanto a la programación, la importancia que tiene a día de hoy aprender programación desde edades muy, muy tempranas. La programación que hoy en día es un lenguaje universal, como la música. Qué bonito, ¿no? Bueno, en definitiva, una educación innovadora, facilitadora, esta palabra a mí me gusta mucho también, facilitadora, que haga un poco más fácil el día a día de todos estos agentes involucrados dentro del ecosistema educativo. Me gustaría recordaros, para empezar, ese hashtag maravilloso oficial que tenemos, almohadilla, lo tenéis por todas partes, Tech Congress BCN, también que tenéis a vuestra disposición la aplicación móvil. Sabéis que tenéis toda la información de la jornada en los canales digitales, por ejemplo en la app, que los que estáis desde casa, los que lo estáis siguiendo desde el streaming, hola, ¿qué tal? Buenos días. Tenéis a vuestra disposición la app, por cierto, también para intentar comentar de forma efectiva todo lo que está pasando y que podamos ver vuestros mensajes, los que estamos aquí, en el muro virtual de la entrada. Y para los que estamos siguiéndolo de forma presencial, que de verdad, permitidme volver a decir que no sabéis el lujo que es ver tantas caras en 3D, por fin. El auditorio completamente a reventar. Enhorabuena de verdad a EduTech, al clúster, porque la organización está siendo maravillosa, de verdad. Os decía, vosotros vais a poder escribir posits virtuales en la entrada también. Luego os voy a explicar un poquito más en profundidad esto. Antes de dar, digamos, por presentada oficialmente esta inauguración, me vais a permitir que haga una mención especial al Departament d'Educació de la Generalitat de Catalunya i al Departament de la Vicepresidència i Polítiques Digitals i Territori de la Generalitat de Catalunya. Vamos a recibir con un fuerte aplauso a Carles Suero. Él es director corporativo de SM Educamos. Un aplauso para Carles. Muchas gracias. Menos mal que había 3 escalones, imagínate. Sí, no. Y el escenario es más o menos bajito. Está bien pensado. Muchas gracias, Carles, de verdad, por el esfuerzo. Me gustaría... Muchas gracias, Ramón. Me gustaría arrancar, si te parece, con esta segunda jornada contigo. Vamos a hacer una brevísima entrevista, pero supongo que SM Educamos no es un desconocido para nadie, pero ¿te parece si en 30 segundos explicamos, por si hay alguien que nos conozca, qué es SM Educamos?
Bueno, SM primero es un proyecto educativo que está implantado a nivel en Latinoamérica y en España. Aquí a Cataluña som Cruïlla. Dentro de SM, una pequeña parte de SM, tenemos un proyecto que se llama SM Educamos, que es un sistema de gestión que está en más de 1.200 colegios en España. Y ahí estamos, pues este es el gran resumen.
Haciendo las cosas bien, claro que sí. Carles, ¿cómo se puede utilizar esta cantidad ingente de datos que al final aportan las plataformas de gestión de los centros para mejorar el día a día, primero del propio centro educativo, que esto es importante, pero también de esa relación con las familias y los propios alumnos?
Vale. Tiro 3 o 4 ideas desordenadas y tal. Primero, una cosa son las métricas y los datos y otra cosa es la capacidad de convertir esas métricas en conocimiento. Nosotros en ese educamos, para nosotros lo principal es esa capacidad de convertir eso en conocimiento. Entonces, reivindicamos o ponemos en valor lo que creemos que es o debería ser, o es, no sé, una nueva competencia profesional, tanto a nivel directivo como a nivel docente, que es lo que llamamos gestión e interpretación de datos para la mejora educativa. ¿Sí? Hablando de mejora educativa, sobre todo. Entonces, quiero poner en valor esa nueva competencia, que es algo a desarrollar y es algo fundamental, porque al final la métrica es la métrica, el indicador se construye, detrás del indicador ya hay ideología y forma de ver las cosas. Luego, otra cosa es que los datos nosotros los vemos no como un instrumento de control y de medida, sino como un instrumento de feedback y de mejora. Entonces, deben ser usados con esta finalidad. Y luego, a pesar de que todos estemos entrando en inteligencia artificial, algoritmos predictivos, y todos estamos, evidentemente es el camino, yo creo que todavía no hemos explotado, estamos lejos de explotar lo que es la analítica clásica de datos, todavía nos queda un gran trecho. Quiero reivindicar también un poquito esto.
Desde luego. Fíjate, a SM Educamos se os conoce como la editorial de los valores, podríamos decir. Esto me gusta mucho, hablando de educación, precisamente porque hay debate, yo creo, en este momento, ¿no? Si nos acercamos a la tecnología desde el punto de vista de un servicio de acompañamiento del profesorado con respecto precisamente a lo que estabas comentando, a ese uso ético de los datos, yo no sé qué opinión te merece al respecto todo esto, porque es verdad que, de hecho, la tecnología tiene muchos detractores, en parte por esto, y sobre todo si involucramos a edades tempranas, como se presupone que tienen los centros educativos, uso ético de los datos.
Primero, nos gusta mucho que se nos conozca como la editorial de los valores. Entonces, nosotros creemos que esto es un posicionamiento, es absolutamente necesario abrir un debate que sea prioritario, principal, sobre uso ético de los datos. De hecho, cuando estaba con el gorro del clúster y del congreso, aquí está Ramón, que os quiero felicitar porque la verdad que es una maravilla lo que yo ya estoy fuera, pero lo que habéis hecho, que seáis capaces de volver a reunir a tanta gente, felicidades y estamos súper contentos. Y ahí cuando hablábamos, ya hace 2 años todos hablábamos como clúster y nosotros como compañía tenemos que poner el debate de la ética de los datos. Esto es fundamental. Ejemplo, a nosotros no me gustaría, pero esto es un posicionamiento, un mundo en el que a mi hijo le coloquen un sensor y le digan si está concentrado o no en clase. Aunque me vendan que esto puede ser bueno para su aprendizaje. No sé, es una cosa que yo de entrada no la veo clara. Eso no quiere decir que no esté de acuerdo. Lo que estamos diciendo es que hay que abrir un debate y no de tecnólogos. Ahí pueden entrar gente con perfil humanista que no tenga ni idea de tecnología, pero abrir este debate de cómo usamos los datos, cómo los gestionamos, la privacidad, etc. Es absolutamente necesario que todos los que estamos aquí, que venimos a un congreso de tecnología educativa, esto lo pongamos como una prioridad principal.
Claro, joder, a mí ¿habéis visto Black Mirror? Seguro. Sí. Lo de colocar un sensor a un niño en clase y te imaginas y que le salte cuando falta educación. Eso es un capítulo de Black Mirror.
Sí, a discutir.
Pero
discutámoslo.
No lo digamos muy en alto, que venimos de una pandemia mundial, faltan los ovnis.
Exacto.
Carles, para terminar, ¿cómo enfocáis las evidencias? Al final, que hablábamos mucho el día anterior, se ha hablado muchísimo de evidencias. Es otra tendencia, que al final decía eso, que constituye una tendencia mundial, muy especialmente en los últimos años.
Bueno, sí. De hecho, yo tengo muchas ganas de escuchar a Geoff Petty. De hecho, nos aproximamos a él hace unos años. Yo, personalmente, el primer libro que leí de evidencias fue el Evidence-Based Teaching de Petty, y yo un lenguaje, una nomenclatura que desconocía, la verdad. Y a partir de ahí, pues ya empezamos, pues vino el libro de referencia a Bajati, a Marzano y a otros autores, ¿no? Y la verdad que eso ha desencadenado una forma de hablar, una nomenclatura, un lenguaje distinto que no teníamos cuando éramos profesores hace 20 años, ¿no? Reivindico la mirada que detrás de la evidencia no hay certeza. O sea, la evidencia dice certeza, pero en verdad la investigación es de ciencias sociales y esto no son ciencias exactas. Entonces, hay un montón de elementos, variables ocultas, elementos de contexto que juegan un gran papel. Las evidencias son una gran herramienta para empezar una discusión inteligente o fundamentar decisiones. pero son eso. Y sobre todo hay una idea de fondo que es, sea lo que sea, como docente o profesional de la educación, focalízate en el impacto. La palabra impacto, que ahora usamos ya como si fuese nuestro día a día, hace 15 años nadie hablaba de impacto, eso es nuevo, ¿no? Pero tener en el radar, y ya no hablo de la sensibilidad cuando estás dando clase, de que al menos tienes que fijarte, ya no digo medir tampoco, fijarte o focalizarte en que alguien esté aprendiendo algo. Para mí esto, aunque parezca muy obvio, es una novedad. Y el lenguaje de Geoff en el libro además es súper próximo, es técnico y a la vez muy didáctico, muy para un profe. O sea que tengo muchas ganas de escucharlo, pero evidentemente todos estamos en ese mundo y entrando con ese lenguaje.
Pues sabes que yo tengo muchas ganas también de escuchar a Geoff Petty. ¿Te parece que empecemos
vamos a lo interesante,
a introducirle?
Sí.
Muchísimas gracias, Carles Suero, director corporativo de educación de SM Educamos. Aplauso para Carles, por favor.
Gracias.
Y yo creo que es un buen momento, si os parece, ahora sí, para presentar a la ponencia marco, entre comillas, digamos, una de las ponencias magistrales del día de hoy, de esta segunda jornada. Él es Geoff Petty. Mientras le preparan, yo creo que ya está preparado, dejadme presentarle. Geoff Petty, como tenemos ya todos los auriculares, vamos a presentarle en inglés para que Geoff se dé un poco por aludido también. Geoff Petty is the author of Teaching Today, Oxford University Press, a best-selling teacher training text. His new book, How to Teach Even Better, an Evidence-Based Approach, updates his evidence-based teaching, and he's been translated all over the world. He has been writing about evidence-based teaching for 30 years. And it's really, really amazing to having you here. Geoff Petty, can you hear me? Big welcome to Geoff Petty, please. Big applause for him. There he is.
Thank you very much for the welcome. Thank you very much. As the title shows, I'm going to be talking about leading practices in teaching, learning, and assessment, making use of evidence. And just as a summary of what I'm going to be looking at, what evidence is there for the relative effectiveness of different teaching methods? That's really important because it enables us to choose which teaching methods to focus on to improve achievement. In general, what makes these effective methods work? And how can we overcome the problems that teachers and institutions have implementing these methods, getting teachers to actually use the methods? And I'm a goal in advance for you. I'm going to give you a quiz later on in the presentation, so do listen carefully. Which teaching methods work best? Now that is a really, really interesting question, and we know the answer to it and have known the answer to it thanks to thousands, about 100,000 experiments that have been done all over the world in classrooms in using a randomized control trial. Now, this is a very systematic way of trialing a teaching method, and it uses a method similar to that used to test drugs. There's a control group, and they're just there for the purposes of comparison. And this is a class which just is taught in the normal way. But there's an experimental group as well. And this is another class, identical in ability, taught by the same teacher, but they're an unusual teaching method is tried. And we're going to test to see whether the experimental group learn better than the control group. And let's just imagine, for example, that you wanted to know whether students learned better if they wrote their own notes. So we're imagining students about 15, 16, 17 years old. They can write. The control group, there's a teacher who's prepared to take part in this experiment, and they've got these two classes. one of which will become the control and one will become the experimental group. The researcher asks the teacher, what do you normally do regarding notes and handouts and so on? And the teacher says, well, I normally teach a topic, and then I give my students handouts, which I've very carefully written over decades, that summarize the key points. And then I review those key points with the students, and we look at the handout together for a few minutes, and then I move on to the next topic. So that's what this teacher normally does. And to be in this research, they'd have to be a really good teacher. So there's also the experimental group, an identical class, which is being taught the same stuff by the same teacher, ideally. And the researcher says, we want to try out students writing their own notes in the experimental group. And this is the way we think you could do it. So the teacher in this experimental group says to the students, I'm about to teach you such and such, but I'm going to ask you to write your own notes on it. I won't give you notes myself. The teacher then teaches the topic for, let's say, 10 minutes or so, puts key words, unusual words, headings and so on up on the board while they do so, while they explain. And then the teacher is quiet. This is remarkably hard in my experience. And the students are asked to write notes about what the teacher has just taught for the last 10 minutes. And they leave gaps between paragraphs in their notes, and they leave gaps down the right-hand side, say, of their note paper to make additions later if they miss something. Then the students check each other's notes and suggest improvements, and they can write extra bits in the spaces that they'd left earlier. And then the teacher says, has a discussion with the class and says, well, under this heading, what did you write? And asks one student to read out what they've written, and then turns to the class and said, well, is that enough? Is that right? And in that way goes through to see whether the students' notes are reasonably okay. Okay, so we've got two groups, identical in ability, being taught in the same way with the same materials, the same videos, the same everything. The only difference is that some students are writing their own notes, and in the control group, the students have been given handouts. There's exactly the same amount of time allowed for this note, for this teaching. Experimental group isn't allowed more time. Then we give the students a test to see how well they've learned after a certain period of time. And actually, I can hear a Spanish translation in my, I don't know whether that's right. If you look at the control group, they will get a graph which looks something like this. Most of the students are getting about 50%. This is the number of students up the left-hand side. Along the bottom of the axis is the percentage that the students get in the test. And you can see some students have done really, really well, and some students have done really, really badly. But most students are getting about just a bit less than 50%. But that's the control group. That's a good teacher doing the normal thing. So let's have a look at what happens with the experimental group. If we did this experiment really, we would find, and this experiment has been repeated hundreds of times, we find that the experimental group learns a lot better than the control group. Their average mark is much higher. We can express this improvement in the students' learning as an effect size. And for statistical reasons, this is expressed in standard deviation. And if we do hundreds of experiments like this, in lots of different colleges with lots of different teachers and lots of different subjects, at lots of different levels, we'll find that the method nearly always works. And it tends to work in most circumstances. And it produces a certain effect size, a certain improvement in students' learning. And that effect size enables us to compare this teaching method with other teaching methods, because if one teaching method has got a much bigger effect size than another one, then that's on average a more powerful method. But here's a question for you. The control group has good notes written by the teacher. The experimental group has poor notes because the students have written those notes themselves. Now, there was a pair check between the students, you might remember, and the teacher checked the notes to a certain degree, and the notes were improved. But if you look at them, and I've done this experiment myself, the students' notes are really much worse than the ones that the teacher would write. So why does the group with poor notes do so much better in the test? I'll give you 30 seconds. Well, let's see what you think. And I'm going to answer the question by looking at some general cognitive science principles. 1, we learn and remember what we have thought hard about. We don't just learn what we've listened to, we learn what we've thought about and thought hard about. We understand new things by connecting new learning to old learning. Students create their own meanings. They don't just remember yours. Learning is a creative process. Students' meanings need to be checked and corrected. They've made these meanings themselves, so there will be errors and omissions in them. So we've got to find what's wrong and put it right. Learning needs to be reused about 6 times to be remembered well. 4 to 6 times. Teachers need to look for any errors and omissions in students' learning and correct these with further teaching. Yes? So these are just general science, cognitive science principles. But if we think about students writing their own notes, I think you'd agree that the vast majority of these cognitive science principles are covered by that teaching method. But suppose we compare this very good coverage of cognitive science findings with giving students a handout. Then the students don't need to think hard. They don't have to connect the learning to old learning. They're not required to form a meaning, and the meanings aren't checked and corrected by the handout really, unless the students may not even read the handout. And the teacher doesn't know the misconceptions and the errors in the students' learning, so the teacher can't correct those easily. So it's not surprising, perhaps, that students writing their own notes is a powerful teaching method. I'd like to go back now, and this is just one little clutch of experiments on one teaching method. There are 100,000 such experiments that have been done on lots of different teaching methods, and they've been collected together by Professor Geoff Petty, who I'm proud to say I work with occasionally. And his work is really seminal because it collects together all of the research that's been done in this way to discover whether this teaching method works better than that, or whether this influence on students' learning is more powerful or less powerful than another one, and so on. His work is best known in perhaps his visible learning books. Let's just see how it works. If we look at the bottom of this diagram, there's lots of different little pieces of research on note making, for example. Yeah, and let's say topic A is note making. So each of those lines is a piece of research, yes, on note making, carried out with different researchers in different institutions and different teachers and different students. When there's about 100 of those individual bits of research, there may be a systematic review. And what happens then is a senior researcher collects together all of the research on that particular topic, on that particular method or influence on students' learning, and systematically chooses the most reliable bits of research. Research, for example, that lasts longer and has more students in it would be allowed in, but a piece of research that was very short and only had 10 students, it would not be allowed in. There'd be a systematic way of deciding which bits of research would be permitted into the review. Then the reviewer looks at all the research, gets an average effect size from all of the research, in a way producing one enormous experiment and finding an average effect size from that, but also looking at whether this method works best with older students or with younger students, or whether it works best with English than with maths or whatever, looking for differences, whether the effect size is affected by anything. And then people like John Hattie and Professor Robert Marzano collect all these bits of research, but it's not just note making that has this systematic review and an average effect size. There's also other methods, so there'd be methods like feedback to students, and there'd be methods like students using computers, and and there's 270 influences, 270 different things that might affect students' achievement, which have been looked at by Professor John Hattie, for example. And Robert Marzano has done a similar job with classroom instruction that works. He's an American writer. What John Hattie finds is that the average effect size, remember this is measured in standard deviation for statistical reasons, the average effect size is about 0.4. In other words, if you look at all of the experiments that have been done, 100,000 of them, if the sort of median, the average effect size is about 0.4, but some things have got an effect size of more than 1, and some things have got an effect size of less than 0.2. So we know which things have got the largest effect on students' achievement. And if you look at which factors overall have the biggest impact on students' achievement, by looking at these studies, we find that students have a very big influence, not surprisingly. A more intelligent, motivated student will learn better. But but we can't change our students easily and quickly, but we can change what our teachers do. And they are the second biggest influence, as you can see here. By comparison, homes have less influence than teachers and what teachers do in classrooms. Peers have less influence. The way the schools are set up and the type of school has less influence. The principal has less influence. So it's what teachers do that has the biggest impact on student achievement if you consider the things that we can change. So if we look, for example, at the effect sizes of some teaching methods, and these effect sizes come from Professor John Hattie. Anything over 0.6 is high, right? A high effect size, much, much higher than the average teaching method. So giving students what's called medal and mission feedback. That's feedback which doesn't grade students. It tells them what they're doing right, a medal, and what they need to work on, a mission. Okay, just information about how well they're done in terms of the goals for that particular sort of learning. Mastery learning, might have time to look at this later. graphic organizers, note-taking, the note-making, you notice there it is. That's got an effect size of about 0.5. So it's not massively high, but it's well worth trying as a teaching method. Giving students challenging goals, rehearsal and memorization, that has an exceptionally high effect size, but it's only about sort of memory. So it's quite easy to get an improvement in that and harder to get an improvement in deep understanding. Spaced practice, where you keep going back to a topic, that's got a high effect size as well. So this suggests a very obvious strategy to me. Having discovered which teaching methods have got the biggest impact, why don't we ask our teachers to try these methods out in their own classrooms? There'd be no certainty that the teacher would be able to make all of these methods work brilliantly. They might not like some of them might not be suited. Fine. There are lots of methods. In my book, there are hundreds of methods that they could choose from. There are bound to be some that will suit. Why don't we get teachers to use these exceptionally powerful methods? Because effect sizes allow us to prioritize the factors that affect attainment. We know what affects attainment most. Let's focus on those. And something really surprising happened when we collect together these 100,000 experiments. We find that the factors that affect students' achievement are relatively unaffected by the subject that's being taught. Students writing notes in history and students writing their own notes in maths, they both work. The age of the student, as long as students can write, they can write their own notes. And you can even get students to do it verbally. There's variations on that method in my books. But you know, if students self-assessing works in primary school, it will also work for a PhD student. The academic level of the student, does not affect the effect size much. And there are many other contextual factors which on the whole don't affect the effect size. However, if a contextual factor does affect the effect size, then the research reviews tell us that. And they say, we've noticed that note making works much better in this context than in that, for example, they might say. Okay, so note making, as an example, just one example of hundreds of methods, has a high effect size. It's been trialed hundreds of times in lots of different subjects, and it's always worked really well, pretty much always. It follows cognitive science principles. And we find, if you look at the research on expert teachers, that they use note making. They get their students to write their own notes. They don't give them handouts. Now, who are these expert teachers? These are teachers who are in the top 1% of all teachers in their nation, about 6 years running. Okay, so they are exceptional in terms of value added. Now, this means that they take students and add an enormous amount of value to their learning in the time that they're with that teacher. It's not, you know, that they inherit very good students. It's that they produce an addition to the students' learning, which is very, very striking. And these teachers, not enough research on this, in my view, but we have got research on expert teachers that shows that which teaching methods they use, and there are some surprises. They don't tend to use the methods which they tend to use the high effect size methods. They've just intuitively worked out that those are good ways of going. So this makes note making an evidence-based teaching method. We've got 3 bits of evidence all saying, hey, try this. We've got effect size, we've got cognitive science, we've got expert teachers. Why not give it a go? It might not work for you, however. I'm not saying that every single teaching method with a high effect size must work. It depends how you use it. It depends whether you like using it. It depends whether your students take to it after sufficient practice with it. But it doesn't matter if it doesn't work for you. Try it a bit, and if you've tried it 5 times in a very small way and it doesn't work for you, try another method. There are lots of methods to try. So we've got what's called triangulation. We've got 3 different ways of looking at the research. And if all 3 agree that the teaching method is worth trying, then let's try it. But it's really important to recognize that your own experience is really key here. You need to use a teaching method about 5 times to discover whether it will work for you and your students. You've got to get used to it. Your students have got to get used to it. And also, the research on teacher improvement shows that even if you've used a teaching method 25 times, you're only about 80% effective at using it. In other words, there's still more power in that method that will be revealed when you carry on using it. So it's important to recognize that improving teaching is quite a challenge and is a real learning experience in itself for the teacher. I myself tried to change my teaching when I was a physics teacher, and I found some teaching methods, I had to use them for a term many more times than 25 times to really feel comfortable with them. Other ones I found very easy to adapt to and to use. But it's a real learning process to adapting to a new teaching method. So identifying highly effective methods is the easy part. Professor John Hattie at Cognitive Science and other research have shown us what methods those are and how to use them. I'm particularly interested in how to use them in my books. The hard part is teachers need to learn how to use these methods. They need to become familiar and they need to become comfortable with them. And they need to integrate these methods into their normal practice, into their scheme of work. They need to, sort of embed them into the way they work. So in summary then, evidence-based teaching is really important. Why? Because teaching methods, strategies and techniques have more effect on how well students learn than anything else that we can change. Some teaching methods almost double the rate at which students learn. Any teacher can use these methods, can learn to use these methods, and so could become an outstanding teacher. Outstanding teachers use outstanding teaching methods. Few teachers have been trained in evidence-based teaching. I wish that teacher training had changed more and been more adept at sort of pushing these teaching methods. And so many teachers are unknowingly using methods that have low effectiveness. And the methods can be used to fix stubborn teaching and learning problems. This is what evidence-based teaching is not. I think there's a lot of misunderstanding about the term. It's not searching for evidence that confirms your gut feelings. Yeah, I mean, if you Google any teaching method, why is such and such a good method, you will get acres of stuff on it, tons of stuff on it. That doesn't prove it's a good method compared to all the others. That's the power of effect sizes. It tells us which methods are more powerful than others. If you say, well, studies have shown that X has improved students' learning, so I'm going to do that, that sounds like evidence-based teaching. It's not. Because there are thousands of methods that improve students' learning, but some only improve students' learning a little. Others improve students' learning massively. So most teaching methods will improve students' learning. We need the ones that improve it most. And managers insisting that teachers must use certain methods, that's not evidence-based teaching either, because the teachers need time to develop their own ways of using these methods. And they need to be in control, not the managers. Using a high effect size method in your classroom, even when it doesn't work for you after 5 or more trials, that's not evidence-based teaching either. You've proved with the most powerful form of evidence, your own experience, that the method doesn't work. Try something else. And abandoning an evidence-based teaching method because the students complain it's hard work, that's not evidence-based teaching either. most of these methods are demanding of students, and students get used to them after a bit. So if they complain to begin with, don't worry about it. They'll soon get used to it. But actually, the vast majority of evidence-based teaching methods are really, really enjoyed by students, because obviously students learn best from methods they enjoy. Here are some criticisms of evidence-based teaching, and they're all fair criticisms. Effect sizes are not predictive. That's true. Just because everybody else finds this method works doesn't mean it'll work for you. You might not be using it well, you might not like it, you might not be using it with passion. So, you know, it's not predictive. It's just an indicator that other people have made that method work exceptionally well, if it's a high effect size. The influences that are mentioned by Hattie and Marzano, they're not recipes. Very often the researchers don't go into the detail of how to use the method in the classroom. They just say note-making is really powerful. They don't know how to do it very often. So we're left there to look at the cognitive science principles and try and sort of work out the best ways of doing it. Some of the research shows exactly how the method is used. Many are not sufficiently detailed. All the data in meta-studies are old. Well, all research is old, that's true. But that doesn't mean that the way students learn has changed all that much in the last 30, 40 years. Many aspects of learning have remained the same. It might not work in my classroom, that's true too. So the conclusion is that evidence-based teaching isn't perfect, but it is the best way to sift the vast pile of research, which we couldn't possibly read all of it, to find the most promising ways to improve teaching and learning in our classrooms. It's a bit like panning for gold. We're searching through, throwing away the sand and keeping the gold nuggets, keeping the really, really high, powerful teaching methods. And we're saying, let's try those. That's what effect size studies show us. And cognitive science principles are incredibly powerful at showing us how to develop these methods and use them in practice. And if we get information from expert teachers that they do it too, then that's real positive. Don't bother to read all of this. You'll have access to this. But I just want to say that there's another issue here. How do we improve teaching? How do we get teachers to make use of these methods? And there's a lot of research on teacher improvement that improves teachers to the degree that students' achievement is increased. So how do we change what teachers do to the degree that their students achieve better? And there are systematic reviews, just in the same way as I described earlier for teaching methods, on this, done internationally. The two major ones are by Helen Timperley and by Vivian Robinson. And the two conclusions I'd like just quickly to draw from those bits of research, which are available free to download. The two conclusions I draw from them are, first, leaders that, I'm talking about principals or head teachers, leaders that concentrate on improving teaching increase student achievement more than those with other priorities. So not all head teachers focus on continual professional development of their teachers, focus on them trying to try out new methods that work really well and so on. They often have other fish to fry, but the other fish don't improve student achievement as much. So that's the research of Vivian Robinson, the impact of leadership on student outcomes. The other thing I'd like to draw from the research is improving teaching is not easy. Most teachers, when you say this teaching method works really well, try it. We'll try it once and say, ooh, that was a bit weird. It didn't, I was out of my comfort zone. I didn't really know quite what to do when such and such happens. So I think I'll go back to doing what I normally do. So there's a problem here. How do we encourage teachers to actually change their practice? Let's have a look at this. And this comes from a systematic review of all research on teacher improvement by Helen Timperley, but there's very, very similar findings by other people's reviews. What you do to improve teaching to the extent that it improves students' achievement is this. You ask teachers, what are your students' learning needs? What do they find difficult? What are they finding hard? What do you have trouble with? And then you say, what are your teachers' learning needs? And let's say a teacher says, well, my students aren't very good at writing essays, so that's their learning needs. And I'd like to use the computer system in my school more effectively. So that's my learning need. So we've got some learning needs, and we would try and find the learning needs that were typical of the whole school. And then we say, and then let's say that most teachers say they want to be able to improve writing skills, or a lot of teachers do in the school or the college. And a lot of teachers say, I need more information on educational technology and how to use it. So we say, okay, what does the evidence base advise on these learning needs? What does the evidence-based say about how to teach students to write? Yeah. So we get out Geoff Petty's book and we look that up. And what does the evidence base say about how to use our particular bits of technology, and so on. And then you get a teacher's plan. Teachers plan some actions, some supported experiments, and maybe also there's some training in the new computer system and whatever. Yeah, okay. So there's a plan now to meet those learning needs. And so let's focus on the teacher trying to develop the students' writing skills. They know how to do it. They've found out how to do it from the evidence, from the high effect size studies, and they do it in a small way. They review that. How did it go? What went well? What not so well? They then learn from that review how to do it better next time, and they then apply that learning when the next time they try it, and they keep trying it in that cycle that I showed there, the do, review, learn, apply cycle. And they try it over and over again, gradually improving. Now, what will aid that process enormously is if you get teachers together into a learning community, a teacher learning community, or a peer coaching team. Here we have about, say, 7 teachers. They're all trying some new teaching method, not necessarily the same one. They get together once every month, once every 3 weeks, whatever, for a short meeting. At each meeting, each teacher in the 6 says, this is what I tried and this is how it went. And the other teachers in that team say, well, maybe your task was a bit too hard for your students. Maybe you could try it like this. Maybe you could try it like that. And each teacher then goes away with an idea about what to do next when they continue trialing the new teaching method. This teacher learning communities of practice, peer coaching groups have been found to be absolutely critical to improving teaching. It keeps the teachers experimenting because they want to have something to say when they meet up in the meetings. And also it gives teachers the support they need and the inspiration they need, because they'll find that some people are doing experiments and they're working really, really well. So they think, gosh, if Jane can do it, so can I. And then there's a review. How effective has the action been for student learning and well-being? That was the aim at the beginning. What were the students' learning needs? What were the teachers' learning needs? And I've focused mainly here on meeting the students' learning needs here by changing the way the teacher teaches. So this is what systematic reviews of all the research on teacher improvement have shown us. And it's teacher improvement, getting them to use high impact teaching methods. That's what will improve students' achievement the most. But practicing teaching methods that are new to you is problematical. You need to try the method 5 times or so to decide whether it will work for you. You need to reflect and improve after each trial, like I've explained. You need to try the method at least 25 times to begin to use it reasonably effectively. You've got to talk with others about your experiments. This is really vital because most teachers will just give up if they don't have this leadership drive to meet in meetings and to talk about what they've tried. And they need to keep trialing the method until it really works well. And once they've found out whether it works, or indeed whether it doesn't, they then try another method. Okay? Now, how does teaching skill improve over a career normally? What happens, and this uses the search of K. Anders Ericsson on all areas of human endeavor, not just teaching. What tends to happen is that your skill of teaching improves very quickly to begin with. We're on a steep learning curve, we say, when we're in our first year of teaching, first 2 years of teaching. But then after about 3 years, we are using methods and they work pretty well. And so we say, hey, those methods work pretty well. I've been teaching 3 years now. It's working pretty well, so I'll carry on using them. That's the fatal mistake. Because if you keep on doing what you've always done, you'll always get what you've always got. The same methods create the same outcomes. So what we've got to do is to get teachers to use different methods, to use powerful methods, to use the high effect size methods that have been confirmed by cognitive science and by expert teachers. And then you get this sort of wiggly line of improvement, because there is a tendency to get an initial drop in skill due to an experiment, but it's only very slight. And the experiments should be short for this reason, just 5 or 6 minutes with a new teaching method, you know? And then you learn, and then gradually you get the improvement. And this deliberate practice approach, as it's called, deliberately trying to improve by doing things new, by getting out of your comfort zone, is what produces an improvement in skill. Okay, here's a quiz. Which of these statements about evidence-based teaching are true? Please pause the video. Yeah, it says, but I'll pause it for you. So if a method is, so here are 4 statements. You might like to do this in pairs. Which of these are true? Any could be true, any could be false. Okay, any could be true, any could be false. I'll give you half a minute. Okay, let's see how you've done. If a method has a high effect size, it's an evidence-based teaching method. No, not necessarily. It also needs to be recommended from cognitive science and preferably from research on expert teachers. However, you could be forgiven for trying it out if it has got a high effect size. Note-making is an evidence-based teaching method, yes. We learn and remember what we have thought hard about, yes. Often forgotten by teachers. Note-making does not require students to improve their notes. Oh, yes, it does. There's a pair check in note-making where the students improve each other's notes, and there's also a teacher check where the notes are improved as well. Those are my references, main references for what we've just been looking at. I'm just going to look very quickly at another evidence-based teaching method, because we've only looked at one. Which of these statements are true? Here's a teacher, diagnostic questions it's called. Here's a teacher who's teaching the concept of area, in mathematics, say. The teacher happens to know that there are some common misconceptions that the students have. For example, 2 meters squared equals 2 meters by 2 meters, yeah, which is not true. That's 4 square meters, isn't it? 2 meters by 2 meters, not 2 meters squared. It's 4 meters squared. So that number 2 is wrong. Number 1 is right, and so on. So what happens? The teacher teaches this topic of area, and when they reckon that the students have learned it, they put these 6 statements up and they say which are true, which are false. And the students then work in pairs to decide. First of all, they work by themselves to decide which are true and which are false. Then they get together in pairs and they check each other's answers, and they obviously talk about the ones which they disagree about. And then the teacher goes through the statements one by one. So the teacher says, okay, area is length times height for a rectangle. Show your answer now. And all the students must show their answer at the same time. And if they believe it's true, they put their thumbs up. If they believe it's false, they put their thumbs down. Immediately the teacher can see who understands that, who does not. And they know which students misunderstand. Yeah. Then the teacher reads the next statement. 2 meters squared equals 2 meters by 2 meters. And again, the students show their answers with their thumbs. And hopefully there aren't as many thumbs up for that one. And so on through. That's called diagnostic questions. It was used by Eric Mazur in university. He calls it peer instruction. It more or less doubled the rate at which physics students, undergraduates, learned physics in Harvard University. It's an immensely powerful method because you're finding errors and omissions in students' learning while you're teaching, and you're correcting them immediately, almost immediately, so the students don't go away with the misconceptions. Okay, I've written a whole book about these methods, and I'm sorry I haven't got time to look at all of these, but they are in the PowerPoint. I'm running out of time here. But what I'd just like to say to finish is that I'd like you to join us in a gentle revolution. Instead of using methods that are traditional, instead of using teaching the way you were taught, instead of using the expected methods that most teachers use in your subject, instead of using the high fashion methods that's just coming up, instead of using the new methods, I'd like you to consider using evidence-based teaching instead. Using methods that have got a high effect size, that are recommended by cognitive science, that are used by the very best teachers. If all of those three things there are true on the right-hand side in that blue box, that method must be worth a go. It might not work for you. Never mind, there are lots of other methods to try. But if we do that, we are focusing on the thing that has the biggest impact on students' achievement. The teaching methods that you use, and we're improving those. But that improvement is a difficult thing that requires that process we looked at earlier of trial and error with the method, having discussions with peers about your trials. So there are lots of evidence-based teaching methods. I'm sorry I've only had a chance to look at 2 here today, but there are lots and lots in my book. Remember that it is best to learn to use these evidence-based teaching methods a few at a time while discussing them with colleagues. And there is a translation of my book that's been done in Mexico, which my understanding is that the Spanish in it was relatively understandable by people in Spain. So thank you very much for your time and your attention, and the very best of luck trying evidence-based teaching out in your institution.
Bueno, tenemos que continuar. Me hace mucha ilusión, por favor, pedirle a Verónica Sánchez, del equipo didáctico de Innovamat, que nos acompañe en este maravilloso escenario. Un aplauso, por favor, para Verónica, a quien entregan el micro de mano. Que vamos a charlar. ¿Qué tal?
Hola.
Ayer, esto es muy bonito, ¿ves? Desvirtualizar a la gente. Ayer Verónica y yo nos vimos en el Discovery Stage. Por cierto, aprovecho para contaros, ya lo sabéis, que ayer, cuando hagamos las pausas, por ejemplo, justo después de venir del café y después de venir del almuerzo, en el Discovery Stage van a pasar cosas. Van a pasar cosas. Ayer pasaron muchas cosas, no podéis perderoslas. Seguid por favor el programa, cotillead la agenda en los canales digitales del evento, porque de verdad os interesan. Y decía que nos vimos, ¿verdad? Y dijimos, eres tú, sí, eres tú. ¡Ey, eres tú! Mañana tenemos una charla. Así que es un placer de ver a Verónica. Oye, cuéntanos, ¿te parece en 30 segunditos qué es Innovamat, para empezar?
O sea, perdón, pero me parece muy extraño hablar de cualquier otra cosa que no sea de la conferencia que acabamos de escuchar.
También.
O sea, ahora podríamos, ¿no?
También.
O sea, cualquier cosa que no sea hablar de lo que nos ha explicado Geoff Petty es como Pero es que nosotros somos una evidence-based teaching company. O sea, corresponde exactamente a lo que ha explicado Geoff Petty. O sea, me parecía como, no sé, como una introducción maravillosa a lo que hacemos en InnovaMath.
Total,
o sea,
de hecho,
gran efecto en el learning de los estudiantes, viene de la ciencia cognitiva y los mejores profesores lo utilizan. O sea, que más claro no puede ser.
Exacto. Y yo voy a echar un cable. Te iba a decir que además InnovaMath es uno de los mejores ejemplos de proyectos para aprender matemáticas en el aula, por ejemplo. ¿Crees que hay otra forma de enseñar matemáticas, Verónica? Tú y yo hemos comentado mucho esto, que quizá no se ha hecho lo suficientemente bien hasta el día de hoy para esta nueva generación de niños y niñas a los que este tipo de plataformas como la vuestra puede ayudarles a que no les pase, por ejemplo, como a mí, que yo tengo que confesar, lo comentábamos también, que yo era la típica niña que tenía pánico a la clase de matemáticas. O sea, no podéis imaginaros, es que temblaba, soy todo lo contrario, en plan, en todo lo demás, era como la primera en levantar la mano y en mates quería desaparecer. Y seguramente era porque no me lo explicaban bien.
Sí, es que este es el germen de InnovaMath, es este. O sea, de pronto, en 2017 hubo 3 ingenieros que se juntaron y empezaron a ver que esto pasaba cada vez más en las escuelas, que había aquí como un gap que no se solucionaba. Y entonces lo que hicieron fue ir a buscar a los mejores expertos y expertas, sobre todo en didáctica de las matemáticas, y decir, vale, vamos a solucionar esto. Entonces hemos organizado, antes eran 3, ahora somos casi 300, y lo que somos una gente muy friki, cada uno en lo nuestro, muchos en didáctica de las matemáticas. Yo soy profesora de literatura, por ejemplo, o sea, no tiene nada que ver, pero es que para nosotros el aprendizaje no tiene fronteras. Entonces, da igual que seas profesor de literatura, que seas profesor de mates. O sea, imagínate, Esther, que en vez de enseñarte las mates como te las enseñaron a ti, como una cosa muy opaca, como muy mecanizada, te las hubieran enseñado como una cosa mucho más abierta, con muchísimas maneras de llegar a las soluciones. ¿no? En vez de enfocarse solamente en numeración y cálculo, que te hubieran enseñado que las matemáticas es resolución de problemas, es probar, es razonar, es conectar con cosas intra y extra matemáticas. Nosotros en secundaria estamos desarrollando una cosa que me parece espectacular con historia de las matemáticas, y hablamos de Mariam Mirzakhani, que es la primera mujer que ganó la medalla Fields de matemáticas, hablamos de Sophie Germain, hablamos de matemáticos indios como Brahmagupta, invitamos a las mates al discurso cultural, y todo esto sin olvidar para nada los contenidos.
Claro.
Entonces es como una visión de las mates que es muy... O sea, que abre las puertas a todo tipo de estudiantes y que... O sea, a nosotros nos enseñaron muchas veces que o servías para las mates o no servías para las mates, ¿no? Tenías que tener como el cerebro organizado de una manera especial, y nosotros no lo queremos para nada, sí. O sea, cualquier alumno es un alumno de mates, y la manera como construimos el conocimiento es para todo el mundo, y cada uno pues llegará a donde llegue de la manera que llegue.
Joder, ojalá hubiera conocido yo de verdad. Es que
eso
esto
lo
digo
también.
mucho.
Sí,
lo digo mucho. ¿Ves? Yo no creo nada en la suerte, pero oye, qué suerte los que hayan nacido en esta generación que van a poder pues, acceder a las matemáticas de una forma mucho más cálida. Verónica, la tecnología, este es un temazo. ¿La tecnología puede llegar a sustituir el papel del profe en el aula?
No. No, nunca. O sea, para nosotros, bueno, pero es que Petty también lo ha explicado. O sea, métodos de enseñanza. Es que da igual, aunque estén basados en la investigación más profunda y más reconocida, lo que más importa es cómo lo utilice el profesor en el aula, ¿no? Dice, lo tiene que utilizar 5 veces por lo menos para que tenga sentido, para empezar, y luego 25 veces para profesionalizarlo, ¿no? Para que realmente tenga como mucho más efecto. O sea, con la tecnología pasa igual. Si es que nosotros, todo lo que hacemos en InnovaMath es para el profesor. Es que, porque nosotros somos profesores casi todos. O sea, es un producto de profesores para profesores. Entonces, nosotros lo que hacemos, tenemos un sistema de acompañamiento y de formación para el profesorado para que esté totalmente capacitado para ser la mejor versión. Y para que, entonces, nosotros, la tecnología para la que lo usamos es para que pueda hacer todo aquello que el profesor no puede hacer de la misma manera. Por ejemplo, recoger datos, ¿no? Los que nos hemos enfrentado a aulas con 25 o 30 alumnos, sabemos que recoger datos de todos estos alumnos es imposible y muy importante. Entonces, utilizamos la tecnología para eso también, para saber en qué momento está. Nosotros tenemos una aplicación que es una pasada, pero no es la parte central de nuestra propuesta. Nosotros apostamos por unas matemáticas manipulativas, competenciales, muy, muy significativas, y tenemos para practicar una app que hace todo aquello que el profesor no puede hacer. Recoger datos y ofrecer como un itinerario como muy personalizado para que la práctica sea lo más eficiente posible. Claro. O sea, cada alumno tiene un itinerario de práctica diferente, con unas ayudas diferentes, y luego esto genera unos informes que los profesores reciben cada semana, y así, cuando llegan al aula, se pueden permitir el lujo de disfrutar de la clase, de enseñar a sus alumnos de manera competencial, porque ya saben que toda esa parte ya la tienen cubierta. Y eso para nosotros es la tecnología. O sea, nosotros utilizamos una expresión que a mí me gusta mucho, ¿no? O sea, ¿cómo podemos ayudar al profesor para que pase de ser un firefighter a ser un firestarter, ¿no? La tecnología nos ayuda con la parte del firefighter y así el profesor se puede dedicar, ¿no? Eso lo decía Plutarco, decía, la mente no es una vasija que se va llenando, que es un poco lo que decía ayer Mark Prensky también, sino un fuego que se tiene que encender. Entonces la tecnología nos ayuda para una parte, para que nosotros en el aula podamos disfrutar de encender el fuego en los alumnos.
Qué bueno, somos optimistas con respecto a la tecnología dentro de las aulas, lógicamente, y bueno, es el mensaje que hay que transmitir, yo creo. Sí,
o sea, no creo que haya nadie aquí que sea pesimista. O sea, no conozco a nadie que trabaje en la educación que sea pesimista. O sea, conozco gente muy frustrada, conozco gente que está muy cansada. Ya entiendo lo que queréis decir, ¿eh? O sea, entiendo las risas y yo también estoy muy cansada. Pero de verdad que, o sea, pero estamos aquí. Yo ayer, o sea, lo hablábamos antes, una de las cosas más chulas de ayer era que se veía que todo el mundo estaba súper contento. O sea, estamos aquí hablando de lo que más nos gusta, no hay pesimismo, solo hay optimismo. Entonces nosotros entendemos la tecnología como una manera de poder ser optimistas precisamente por eso, porque nos libera de unas cosas que son más, ¿no? Como más arduas para el profesor, y nosotros nos podemos dedicar a lo que nos gusta, que es disfrutar del aula, de las clases y de eso, de encender ese fuego. O sea que sí, somos optimistas y seguro que todos lo son aquí también.
¡Qué grande! Un aplauso para Verónica Sánchez, por favor, del equipo didáctico de Innovamat. Gracias, Verónica.